Hello, my name is Matthew Norton. I'm a product owner working in member technology delivery. I work on enterprise data products specifically focused on customer data quality and the protection of data. I have almost 20 years experience in financial services, having worked in analysis, design and project roles for Barclays, Barclaycard, Volkswagen and now Nationwide. Nationwide Building Society is a UK financial services organisation. It's the largest building society in the world with over 16 million active members. Being a building society means that although we offer the same services as a bank, we are run for the benefit of our customers, or members as we call them, and the communities around us, not for shareholders. Today we're going to talk a little bit about synthetic data. So synthetic data allows us to create non-sensitive representational data quickly and at volume. Machine learning techniques are used to train a model based on an original data set, which may contain some sensitive data that you wish to protect, such as customer or account data. Based on that model, synthetic data can be generated on demand, and the original data set can then be discarded. The beauty is that although synthetic data has the same shape, quality, and referential integrity as the original data set, it's completely synthetic, so it doesn't contain any of the original data. For example, customer or account data. So this can be a valuable tool for data engineering, helping us to improve the quality, efficiency, speed, reliability, and safety of data engineering activities. Today, we'll talk through some of the key benefits, potential use cases, and also challenges of synthetic data, especially in the context of a large organization. Alex is then going to do a technical demonstration. So the primary benefit, in my opinion, of synthetic data is privacy. As well as the benefit of retaining the quality and shape of the original data, synthetic data has huge privacy benefits, especially over other privacy-enhancing techniques, such as anonymization or pseudonymization. In these techniques, not only is some of the original data retained, increasing the risk of a data breach or identification of a subject, by removing some of the data in these processes, its usefulness is degraded. Synthetic data solves both of these problems, retaining the quality of the data and the signals it contains, whilst taking the original data away. This is obviously a huge risk reduction. And whilst there are ways to use live data with appropriate controls, this also takes effort. So there are associated costs and time savings, as well as the risk reduction benefits. Volume of data. From a relatively small sample, or just a schema even, you can generate whatever volume of data you need. Regardless of the risk of moving volumes of data around, the ability to create meaningful data quickly at volume allows analysis, delivery, and innovation to move at a far higher pace. For example, a couple of years ago in Nationwide, we created a synthetic version of our entire customer base of 16 million active members in around 15 minutes to support our digital development teams. In fact, we got the data to them quicker than they could get the people to do the engineering. Rare events. So if you want to, for example, look at studying fraudulent transactions happen all too often, but not are relatively rare in the context of the wider transaction stream of millions and millions of transactions on a daily basis. So with synthetic data, you can reproduce data with more of a prevalence of those rare events. So you can increase the signal of relatively rare events within the data sets and use those events to accelerate in compressed timelines the value and efficiency of the analysis around those events. For example, you may be wanting to do some data modeling or training of an AI or machine learning model. Collaboration and innovation. So let's say, for example, you'd like to bring in a range of external partners to help you identify ways to improve your business through innovation. You can share data that's relevant to your organization and the needs you're wishing to meet, even at early tendering processes, without having to put massive controls or process around showing that data. So whilst protecting the data, its value and the consents of the subjects of that data, you can also share useful data almost instantly. So how about use cases? So specifically within the context of data engineering, let's talk about some specific use cases that synthetic data can be applied to. The first is data pipeline testing. So you can check the ETL processes work properly. You can check data integration workflows operate effectively, identify potential issues, and ensure that processes and transformations work correctly. Also, wider testing use cases. There are lots of instances, in my experience, where live data might be used for testing, but synthetic data can be just as good and obviously a lot safer. You can use it for unit testing of individual software changes. You can use it for database schema testing, so ensuring data is stored and retrieved correctly, and testing data models. You can use it for integration testing between different applications or APIs and data sets. You can use it for performance testing, especially you can generate data at huge volumes, even bigger than the live data sets it's based on. And you can use it for security testing. This might include, for example, cloud migrations. Finally, data modeling and analytics, which is a really useful and exciting use case. You can use data safely in that volume to increase model training efficiency. For example, you may be doing some credit risk modeling or fraud modeling. Furthermore, this can be enhanced through augmentation of the synthetic data with real data, which can add further value. And also, as discussed earlier, the generation of repeated rare events can increase model training efficiency in a compressed timeline. Obviously, it might sound like synthetic data is too good to be true, and it is a very powerful tool. But as with anything, it comes with its challenges. As with any new technology, infrastructure and investment and prioritization of it is required to get the capability off the ground. The machine learning aspect in particular to train synthetic data models can be resource hungry, even in short spurts. We've found that deploying to cloud environments as opposed to on-premise has made this far more effective as you're able to scale. So the appropriate infrastructure needs to be in place to make this offering viable. Knowledge and expertise. So experience and knowledge doesn't always exist at the right level, as this is a new way of doing things. In particular, in a large organization, you need the right critical mass of people to do things at scale. One solution is partnering with third-party providers who have that expertise, as we have done at Nationwide. You can use their specialist resource to help build up organizational experience and knowledge, but also bringing in the capabilities and competencies to deliver things quickly. And lastly, culture change. So again, with all new ways of doing things, you're always going to focus, always going to face the problem of this is not the way we do things around here. This is especially true where there is inertia for existing methods, even if in the long term they may be less effective and not safe. Therefore, in my opinion, the key is starting with small individual use cases to prove effectiveness, efficiency, and value. Once you've done that, you'll have the stories to tell to gain the required buy-in and investment needed to scale. So in summary, today we've walked through the benefits of this exciting technology, including volume, rare events, privacy, use cases where it can add value, so innovation, collaboration, different types of testing, and also analysis and data modeling. But we've also talked through some of the challenges you may face, in particular in a large organization. In a second, then I'll hand over to Alex for a practical demonstration of this capability. Before that, though, I'd just like to say thank you for your time today and for listening to my presentation. If you'd like to get in touch and like to discuss further, it'd be great to hear from you. My contact details are on the slide. Matthew.norton@nationwide.co.uk on my telephone number, or if you search for me, Matthew Norton at Nationwide via LinkedIn, you should be able to find me there. Look forward to hearing from you. Enjoy the rest of the day. Over to Alex. Thank you.
Hello. Thank you, Matt, for introducing use cases for synthetic data. My name is Dr. Alexander Mikhalev, and I'm going to take you through the short demo of synthetic data using open source tool called Synth. Let me share my screen so it will be more enjoyable. Right. So Synth is the open source tool, as I mentioned. It's available on GetSyn website. It's written in Rust and it's extremely fast and memory efficient. It was originally developed by Shuttle team, who since then pivoted into building Shuttle platform, for hosting platform for Rust developers, and now Synth is maintained by Sam and myself. So as a starting point, we'll install it. So I have it installed, but it is a one-liner. And what I'm going to demonstrate first is how to apply synth and generate synthetic data for typical IoT use case, where you have a IoT sensor, you have a MQTT server, which collects data from sensors, and then you have a streaming cluster, which in this case is Fluvio cluster hosted on Infineon platform, and it grabs the data from MQTT server using a MQTT connector. Then it creates a Fluvio topic, then it does JSON to JSON transformation, and then JSON to SQL transformation, and then writes SQL into outbound Postgres database. Right. So let me show you the cluster. So as you could see, it's Fluvio Cloud Connect, and you could see I have two connectors. One is MQTT and one is SQL. And for MQTT, we are going to use public Mosquito broker, and I'm going to show you config. Yeah, so we are using public Mosquito broker, test Mosquito, and we are going to populate our data into M1 MQTT topic, and then it will arrive into a Postgres database, which is here. So you could see I currently don't have any messages in topic message 1, which is configured to receive output of the Fluvio topic into Postgres database. So what I'm going to do next, and I'm going to walk through first, generate synthetic data, feed them into MQTT broker, and then demonstrate how whole pipeline works. And then I'm going to explain step by step what happened. Right. First step, I'm generating synthetic data. That's it. That's already generated. And if we want to generate more, we can generate 50,000, 550,000. As I mentioned, the tool is pretty swift. And then what I'm going to do is I'm going to pump that data into Mosquito broker. Then the reason why I wanted to show the config is I'm going to check that Fluvio consumes MQTT topic. So already populated data. Well, actually, so this is a Fluvio MQTT topic consumer, but it only started, so it haven't seen data which we populated into topic before. So I'm going to open another window and just repopulate it. You could see there is a MQTT data in Fluvio topic, so MQTT connector worked, and now we are going to see it worked. It was populated into SQL database. So that's the first use case for synthetic data, where you can validate advanced real-time machine learning pipelines or streaming pipelines or data transformation pipelines using synthetic data. So what I have done in that case is I didn't have original data, but I wanted to validate pipeline. So it is a top-down approach. I went to Cloud Events website, which is common specification for generating data for IoT. And then I created two files, roughly 3, but 2 are the most important ones. One is according to specification of Cloud Events, payload can be serialized XML. It can be a JSON list, which is that one. Or it can be typed data, like a digit, where you can see 1.5, or just a string, or base 24 encoded. So what I wanted to make sure in that my pipeline can handle any type of data which are generated by MQTT sensors according to cloud event payload. Next step is, and the way how I called it is, so I have a sensor data with another config file, which is in front of your eyes at the moment. And I have, I'm calling that different data payloads as IoT data JSON as a data source. And there are different types, as you can see in front of you. You can generate numbers using a range, the different steps. You can generate different subtypes. You can generate date times and timestamps and various formats. But I would like to reiterate that this little trick, which is where we used external configuration file as a source of the JSON data. And then in that particular file, there is one more trick where I'm referencing device ID as a content of another file, which is called device, which is too boring to present it to you. And then we can generate as much or as little synthetic data as you want in one go. So let's do 50,000. And generating 50,000 sensor data takes under 3 seconds. So what we have done now, we took an external specification. We have built the pipeline, which is in modern days, you can build MQTT to SQL in 10 minutes or less. And we generated synthetic data to validate the pipeline. And what we also can potentially do, and that's another use case for synthetic data, is where we do it in reverse. So let's say bottom-up approach. Let's say you have a Postgres database, and you would like to build the synthetic data from Postgres database, which allows you to populate non-production environment for Postgres and then test it using various CI/CD tooling. Synth, despite being fairly simple, have a Postgres adapter, which allows you to import data from the Postgres. And that's what I'm going to demonstrate to you in a minute. So I have another database, which is a Neon database, which is a free server again. And let me log into it. Yeah, confirm the login. All right. This is out of our test harness. So, and if you look into Synth source code, it will have a same example, and that file also demonstrates the same data. But I'm going to back to my presentation. So this is a table of doctors, hospitals, and patients. And they have connections, and what we can do is we can point the synth to our database. So let me create it. And then we can import the schema. The challenge with this approach today would be that it's not fully created schema. So, and I already tried it before demonstrating it to you. So that's why it failed on the first attempt. But what happened now is we generated JSON files out of database schema. And if there are data and data types, particular categorical data types, synth will try to infer these data types. You may still need to edit those files, and I would refer you to synth documentation because we provide different types of the generators for different data types, and you can have like daytime generators, or you can have a same as, or you can have a categorical or time series generators. But we also have fakers, which are similar to Python generators, where you can generate address, first name, last name, title, or credit card number, or email provider. Once you are happy with your configuration schema for the synth, you don't have to generate data into files. You can generate synthetic data directly into database. So you can pass the to Postgres URL and again schema and the namespace. Namespace should exist for it to work. It's obviously not going to work if I'm going to generate it back into my current database, but synth will generate data directly into Postgres. It will generate as much data as required, and you can pass size parameter, as I demonstrated you earlier, to generate hundreds of thousands or millions of rows in one go. And then synth will respect primary keys and foreign key constraints, and it will perform topological sort on data before inserting it in the right order, so no constraints are violated. And one of the most interesting and practically useful aspects for synthetic data is that once you generate synthetic data, you can use synthetic data generators to build your own integration tests. In the same way how I demonstrated to you today that you can take import schema and then you can generate data back into Postgres database, you could make it part of your integration tests. And that's where that's example out of our test harness. And you can generate hospital master, and it checks that it generated 30 records using select count. And I believe that's a really powerful way to create integration tests for complex machine learning pipelines or data transformation pipelines, where you could generate synthetic data, you could feed them directly into database, or you could feed them into the beginning of the pipeline, like I have done with MQTT to Postgres transformation, and then validate that the schemas matching in SQL database using simple select or using select div between synthetic data and the landed data. So the synthetic data generator becomes like a master schema for testing data. So it's like virtual tables, which you then can generate and turn it into JSON and feed it into MQTT, or you can turn them into SQL and insert them directly. And then you can validate that what landed after all transformations landed with the same data transformation and what you're expecting. And that can be purely applied into CI/CD. And as I said, that's actual example out of our code repository. So we also have a bank data tutorial or log data tutorial. Hospital is not a tutorial, but it's part of our CI pipeline. And we have a few ideas how to improve synth, and I hope it will be practically useful for you. And if you'd like to learn more and contribute, Star our GitHub project page, join us on Discord channel, or email to me at alex@metacortexengineer. So thank you very much for listening.